Welcome back to Sales MBA. As always, I start with my motto, I'd rather be good than lucky. Our goal is to use deep learning for confidence, credibility, and direction. Today's topic is decision intelligence. So to set the stage for our discussion, let's take a look at and talk about the current state of enterprise decision making. If you look at the top layer of the visual, you'll see where the industry has spent the last decade. We have effectively solved the analytics problem. Most large organizations today are full of dashboards, they have sophisticated forecasting models, and they have no shortage of data. They know exactly what is happening. But here's the friction point. High quality insight does not automatically lead to high velocity decisions. This gap represents what I call decision latency. It's the time lost between seeing a signal in the data and actually taking action in the real world. In today's volatility, this latency is where value is destroyed. It's the meeting that happens 3 days after the supply disruption, or the manual handoffs required to execute a plan that is already a week old. Decision intelligence shows the need to stop optimizing for better reports and start optimizing for decision velocity. We need to move from decision support, which just gives you advice, to decision execution, which closes the loop to drive action at the speed of the market. Let's double down on that concept of decision latency because it is the single biggest hidden tax on your performance today. If you look at this timeline, point A is the moment data tells us something has changed. Perhaps a shipment is late or demand signal is spiking. Point D is the moment we actually execute a fix in the system. The time in between points B and C is the friction. It is the time consumed by analysis, internal discussion, email chains, and approval meetings. The problem is that during this delay, reality drifts. By the time you finally execute the decision at point D, the assumptions you used at point A are often already wrong. In supply chain, this latency manifests as expediting costs because we reacted too late to a shortage. In finance, it manifests as working capital drag because inventory wasn't adjusted fast enough. Crucially, we need to recognize that these are not failures of intelligence, they are failures of structure. We are trying to run a high velocity business using low velocity tools like spreadsheets and meetings. To fix this, we need a system designed to explicitly compress this timeline. To fix the latency problem, we have to first fix the vocabulary. The market is currently very noisy. Everyone claims to do AI, but few vendors distinguish between predicting a problem and actually solving it. Decision intelligence is viewed not as a single tool, but as a stack of four distinct capabilities. Mature companies likely have the bottom three layers already. Layer one is sensing. This is machine learning. It answers what is happening by detecting patterns and anomalies. Layer two is optimizing. These are the math engines. It answers what is the best action by solving for constraints like cost or capacity. Layer three is reasoning. This is scenario modeling. It answers what are the trade-offs, helping executives compare options before committing. The reason outcomes still lag is that most enterprises stop here. They have great insight, but they lack layer four, executing as a system capability. This is where agentic AI sits. It doesn't just give you a report, it creates a bridge to action. It takes the insight from the bottom layers and actually writes the decision back into your transactional systems. Please do not view this as a maturity curve where you graduate from one level to the next. This is a system. A mature enterprise needs all four layers operating simultaneously. Companies may ask, why are we still slow despite all of our tech investment? The answer is usually that they have a strong sensing and optimizing capabilities, but are missing the execution layer that closes the loop. Okay, let's dig deeper. We begin at the foundation with layer one, sensing. This is the domain of machine learning, and it's where the vast majority of enterprise AI investment has gone over the last several years. The goal of this layer is to answer a specific question like, what is happening and what is likely to happen next? By applying techniques like neural networks or regression analysis, organizations can now detect patterns on demand, supply, or logistics data that would be invisible to the human eye. However, this is where the confusion begins. We must be very clear that prediction is not decision. Machine learning is probabilistic. It deals in likelihoods, ranges, and confidence intervals, not certainties. It describes the environment, but does not know the strategy. For example, this layer can predict with high accuracy that a shipment will be late, but it cannot tell the business whether to pay for expediting, to protect on-time delivery, or to accept the delay even though it may push out billing and cash collection. Sensing creates awareness, but it stops short of telling an organization what to do. Moving up the stack, we reach layer two, optimizing. If sensing answers what is happening, optimization answers what is the best action. This is the domain of deterministic mathematics, linear programming, and solvers. This layer is designed to look at limited resources such as inventory, factory capacity, or budget, then calculate the most efficient way to allocate resources to meet demand. Unlike machine learning, which deals in probabilities, optimization deals with rigid rules. It produces a mathematically engineered plan based on the constraints provided, and the same inputs will deliver the same outputs every time. However, this layer suffers from a critical structural weakness known as the timing mismatch. Optimization engines require a specific snapshot of the world to run their calculations. They create a plan for the world as if it existed at the moment the calculation began. But in a volatile supply chain, reality shifts immediately. A truck breaks down, a supplier decommits, or a rush order arrives. The moment these inputs shift, the optimal plan becomes invalid. This forces planning teams to abandon the system and revert to manual spreadsheets to manage the exceptions. Optimization calculates what should happen, but it cannot adapt quickly enough to ensure it actually happens. So we now reach layer 3, reasoning. This is the domain of scenario modeling and integrated business planning. If layer 2 calculates mathematically best answer, layer 3 allows leaders to ask, is that answer that we actually want? This layer is essential because business is a game of trade offs. Leaders have to often choose between conflicting objectives, such as maximizing revenue versus protecting margin, or carrying extra inventory versus freeing up cash. Scenario modeling allows the organization to compare these features side by side before committing. But this is also where the decision stack hits a wall. We call this the execution gap. While the analysis in this layer is advanced, the execution remains entirely manual. Once the executive team selects scenario B, for example, in a monthly S&OP meeting, that decision is usually handed off via email, spreadsheets, or verbal instructions to operational teams. This handoff creates a massive disconnect. The system prepares for the decision, but it relies on humans to bridge the last mile into the transaction systems. By the time the teams interpret the instructions and key them into the ERP, the market conditions that drove the decision have already changed. The logic was sound, but the execution was too slow. Okay, this brings us to the core friction point in the modern enterprise. Most organizations have invested heavily in layers 1, 2, and 3. They have the forecast, the solver, and the planning deck. But stacking tools does not create a system. Instead, these layers function as a chain of partial answers. The forecast says what might happen, the plan says what should happen, but nothing connects these insights into action except manual effort. This disconnection creates three structural failures. The first is the timing gap. Forecasting often runs weekly, planning runs monthly, yet reality changes daily. By the time insight travels from one layer to the next, the data is often already stale. Second is local optimization. Each layer solves for its own narrow metric, forecasting accuracy, or shipping efficiency rather than solving the total business outcome. The parts are optimized, but the whole is fragmented, and that's important. Finally, there's unclear ownership. Because the process is split across disconnected tools, no single system is accountable for the final result. If a decision fails, it is unclear whether the error was in the data, the plan, or the execution. This breakdown explains why enterprises can be data rich yet remain execution poor. Components are strong, but the connections between them are broken. So we now reach the top of the stack, layer 4 execution. This is the missing link in the modern enterprise architecture. While the bottom three layers, sensing, optimizing, and reasoning, provide decision support, they remain advisory. They produce charts, plans, and recommendations that wait for human intervention. Layer 4 is the shift to decision execution. This is the domain of agentic AI. Unlike traditional automation, which follows rigid, pre-scripted workflows, agentic AI is intent aware. It understands the business goal, such as maximize fulfillment, and it figures out how to achieve it. Crucially, these are agents that operate within guardrails. The system does not improvise strategy. It executes autonomously only within the specified safety boundaries, such as margin floors or service targets, as defined by leadership. This layer bridges the last mile. It takes the insight from the bottom layers and actually writes the necessary actions back into the transactional systems, updating a purchase order or reallocating inventory without requiring a manual keystroke. Finally, this is execution is continuous. While planning layers run on monthly or weekly cycles, the execution layer runs 24/7, monitoring signals and taking action the moment conditions change. And that's a huge game changer, the continuous function. To implement layer 4, the operating model must shift from an open loop to a closed loop structure. Today, most organizations operate in an open loop. Data is analyzed, a recommendation is generated, then the process stops and waits for a human review. Once the human acts, often via email or a spreadsheet, the link between the insight and the outcome is broken. In this model, outcome is rarely tracked back to the specific decision that caused it. The organization executes, but it does not learn. Closed loop decisioning changes this by treating the decision as a continuous system rather than a one time event. It consists of four connected steps: sense, reason, act, and learn. Two specific capabilities make this loop closed. First is direct execution. The system does not just display a recommendation, it writes the action directly into the transactional system, such as SAP or Oracle, without requiring manual keying. Second is observation of the outcome. The system automatically tracks the result. Did the shipment arrive? Did the inventory rebalance? And links that result back to the original decision logic. By closing the loop, the enterprise moves from managing by exception, waiting for things to break, to managing by design, where the system continuously corrects its course. This leads us to the most powerful output of a closed loop system: decision memory. For the last decade, the industry has focused entirely on data memory. Massive data lakes have been built to store facts, sales figures, shipment dates, inventory levels, but storing facts is not the same as storing experience. Data tells you what happened, decision memory tells you why you acted and how it turned out. In this new operating model, the system captures a complete decision record for every action. As you can see here, it records four things simultaneously. The context: what did the world look like at that moment? This is the data snapshot. The logic: why did we choose this path? The trade offs and the rules that were applied. The action: what was actually executed in the system? Better yet, the outcome: did it work? This creates a learning loop. Because the system links the specific outcomes back to the specific logic that produced it, it can refine its behavior over time. And this is key. If a decision to expedite shipping improves service, the system reinforces that path. If it erodes margin without solving the problem, the system adjusts the logic for the next time. Finally, this solves the crisis of institutional memory. Today, when a senior planner leaves your organization, the institution walks out the door with them. The decision memory, the reasoning stays in the system, allowing the enterprise to become smarter over time rather than resettling every time a team member changes. A common fear regarding agentic AI is that it removes humans from the loop. To be precise, agentic AI does not remove humans from decision making. It removes humans from the critical path of execution. Today, most organizations rely on humans to bridge the gaps between disconnected systems. Humans extract data, interpret spreadsheets, and hold meetings to align on actions. We call this legacy model managing by meeting. In a decision intelligent operating model, the human role elevates from operator to governor. Instead of performing the execution, leaders focus on three higher value responsibilities. First, defining intent. Humans must explicitly define what the system is optimizing for, such as maximizing revenue or preserving service levels. Second, setting guardrails. Humans define the hard limits of safety and risk, such as never drop margin below X% or never expedite air for this customer segment. Third, reviewing outcomes. Humans evaluate whether the strategy worked. If the system executes within the guardrails but the outcome is poor, the human adjusts the strategy, not the individual transaction. This shift allows the enterprise to move to managing by exception. The system handles the high volume, repetitive work of coordination and execution, while humans intervene only when the system encounters a novel situation or a conflict it cannot resolve. Ultimately, the goal is to stop using valuable human talent to copy paste data between tools and start using it to shape the strategy that the system executes. We often hear that the supply chain technology landscape feels incredibly crowded. However, when we map vendors against the decision stack we just discussed, a clear pattern emerges. Most technology investments to date have focused on the bottom three layers: providing visibility and better planning. At the foundation, companies have prediction platforms like Blue Yonder or Relics. These tools are excellent at sensing. They ingest massive amounts of data and forecast demand to detect early signals of change. Above that, organizations use planning suites like Kinaxis or SAP IBP. These tools focus on optimizing. They take the forecast and run complex calculations to determine the best theoretical plan based on constraints. Next, we see IBP and scenario planning platforms like Anaplan or O9. These are used for reasoning. They allow executives to model different scenarios and align on financial trade offs before locking in a strategy. However, all these platforms share a common limitation: they stop short of execution. They generate a forecast, plan, or a recommendation, but they ultimately rely on a human to log into a separate system to make the change. This is where Agentic AI fits. As shown by the top block, it does not replace the planning or forecasting engines. Instead, it sits on top of them to own that last mile. It consumes the insights from the layers below and creates the bridge to the transactional systems. This completes the architecture, turning a suggested plan into a completed action. When organizations ask about readiness for agentic AI, the conversation almost immediately turns to data quality. There's a pervasive belief that the enterprise must clean all of its data before it can begin automating decisions. This is a trap. Readiness is not a technology checklist, it's a clarity checklist. To begin, an organization does not need perfect data. It needs the ability to describe a decision in a way that can be engineered, governed, and repeated. Specific criteria determine if a use case is ready for this transition. First is decision clarity. Can the business name the specific decision? Improve service is not a decision, it's a goal. Transfer stock from hub A to hub B is a decision. Secondly, is the accountability owner. Is there a single person with the authority to say yes to the outcome, even if the decision crosses functional lines? Third are defined guardrails. Can the organization articulate the specific constraints, such as never expedite if margin drops below 10%? That defines the boundaries of safety. Fourth is the execution path. Do we know exactly which system needs to be updated? To automate a decision, we must identify the specific write back target, such as a transfer order in SAP or a parameter change in the TMS, and understand the control points required to make that change. This brings us to the most important insight regarding data. Data trust is improved by the decision loop, not before it. When a system attempts to execute a decision and it fails due to inaccurate lead time or a missing inventory record, that data error becomes the operational priority. The organization fixes the data specifically to fix the decision. Waiting for perfect data across the enterprise is a recipe for permanent delay. Starting with clear decision logic is the fastest path to actually cleaning the data that matters. Once we have established readiness, the next question is implementation. A common mistake is believing that agentic AI requires a big bang launch, flipping a switch to turn on full autonomy overnight. That approach fails because it generates fear rather than trust. Instead, we follow a crawl, walk, run progression designed to build confidence at each step. Step one is the sandbox phase, or the crawl. Here we validate decision logic against a historical data set without touching live production systems. We ask, if the system had been live last month, what would it have done? This allows cross-functional teams to debate the logic and refine the rules in a completely safe offline environment. Step two is the controlled pilot, or the walk. This is a human-in-the-loop model. The system connects to live data and generates recommendations, but it does not execute them. It presents the decision to a human operator for approval. We call this digitized automation. It proves that the system can handle real-world constraints and allows the human workforce to verify that the guardrails are holding. Trust is built by seeing the system get it right repeatedly. Finally, we reach stage three, autonomy, or the run. Once the pilot proves stability, we enable agentic execution. The system begins executing decisions automatically, but only those that fall strictly within the approved guardrails. Humans step back from approving every transaction and focus entirely on managing exceptions. This roadmap ensures that autonomy is not a gamble, it's an earned capability that expands only as trust and stability are proven. We arrive at the final slide, which answers the question, what is the ultimate value of doing this? The traditional answer would be efficiency or automation, but the true value is much more profound. The outcome of a closed loop system is compounding decision quality. In the current reality, volatility is no longer an exception, it's a permanent operating condition. You can continue to throw human effort at structural gaps, adding more meetings or more spreadsheets, or you can build a system that learns and acts at machine speed. The winners of the next decade will not be the companies with the best data. They will be the companies whose decision systems improve with every action taken. This creates a compounding advantage. Enterprises rarely win by making one genius decision. They win by making thousands of operational decisions slightly better, slightly faster, and slightly more consistently than their competitors. When you have a system that learns from outcomes, your advantage just doesn't add up linearly. It compounds like interest. Early gains may look modest, but over time, the gap between you and your competitors widens until it becomes impossible to close. This is the shift from managing by exception, where you wait for things to break, to managing by design. So, the final call to action is this: stop buying more insights, start building a decision system.